Hello and good afternoon. My name is Carrie Siliberto, and I'm the CEO of the HBA. I want to thank you for joining today's webinar, The Top 5 Signs of Structural Stress, sponsored by HBA member Centricity. We are very lucky to have 3 Centricity representatives with us today who will provide you with information to help you, your clients, and your business. Just a few quick housekeeping items before we get started. You will have an opportunity to ask questions of our speakers. Please type your questions in the questions box and we'll get to them at the end of the presentation. You will receive a copy of the PowerPoint and the recording. GoToWebinar will send you the recording about an hour after the event, and we will email you the PowerPoint. So please be sure to check your spam, as the email from the HBA will come from info@. We are very lucky to have such knowledgeable and generous HBA members to talk with us today. Mike, please take it away.
Hi, thanks, Carrie. I appreciate it. First off, happy Cinco de Mayo to everybody. My name is Mike Kelly. I'm the VP of National Sales with Centricity, and we are a structural home warranty company. We've been covering builders in Texas and across the country, not only in the structural home warranties, but other builder products as well to help you protect your assets. We'd like to also say thank you to Carrie and the HBA for having us today. We've been proud partners with them for over 15 years. Again, serving the greater Austin, Texas, and across the country with our products. Today, we have a few people on our panel. Lisa Hall is a regional sales manager. I will introduce her. She can say hello.
Hi, everybody. It's great to have you all listening, and we're really honored that you're listening with us today. And thank you so much. I want to let you know that I'm here for you if you have any questions or have any needs on structural warranties. I've been around in the Austin area for over 11 years and very well knowledgeable on what's here in our industry and the builders. So anyway, with that being said, I'm going to give this to Brant to take it away.
Hello, everyone. What does a typical foundation failure look like? I'm asked this constantly by builders and our sales team, and so it's essentially what we'll be talking about today, and hopefully when I'm done, you'll have a clear understanding what a foundation failure looks like. So is this an example of foundation failure? It's pretty horrific crack there. Is this an example? This builder decided to build this house in a filled-in drainage ditch, and it didn't go well. After about 12 months, the house began to settle. What about this alligator grin in the side of the house? Most likely a cold joint. What if somebody sent you a picture of this house? If you were to walk around it not opening the exterior doors, it would have a few cracks in the stucco. Didn't look so bad. If you were to look at the elevation diagram the engineer sent, you can see the back right corners of about 3 inches. What did the homeowner say in their online complaint? They said racking of windows and doors, cracking of the interior and exterior veneer, exit doors have moved significantly. So, do you think it was a failure? It was. It cost us about $103,000 to repair. For houses that fail in heat and we have to pile them, they generally cost between $75,000 and $150,000. So it's very expensive to repair a foundation. So what is a foundation failure? This is what ASCE says a foundation failure is, and ASCE stands for the American Society of Civil Engineers. The Texas chapter in the early 2000s came up with a definition that our company uses a modified version of, and essentially they say that there are 2 modes of failure. One is a deflection, and deflection is the bending or angular distortion of the foundation, and tilt, which is the planar rotation. So the definition of deflection is characterized by the deflection ratio, which is the maximum deviation from the straight line between 2 points divided by the distance L, which is in inches, between 2 points, and typically is referred to as L over 360. Foundation tilt is the planar variation from a level condition to one that slopes across the entire foundation, and generally 1% or more is considered a failure. So if we looked at an illustration of this, the top example, deflection, the very dark line is the foundation. And if you could graph it kind of as an exaggerated style, you can see at the front and the back of the house it heaved about 2 inches. If you draw a straight line between those 2 points, assuming the slab was poured perfectly level, you would measure the maximum deflection, and that's indicated in the middle there. Tilt, in this example here, the slab is very wavy, but if you measured the tilt, that would be, again, the straight line. Keep in mind that when you measure deflection and tilt, there has to be a corresponding amount of distress in the house. I once walked through a house years ago that was 14 inches out of level. There was no distress at all in the house. It was tilted so badly that the balls of the pool table wouldn't even sit on the table without rolling to one end. It was poured that way. Did not tilt on its own. So what causes these situations? Much of the U.S. is covered in expansive soils. This map happens to show where the most expansive soils are. And those of you who may not know what expansive soils are, those are soils that when you add water to them, they swell. And when you remove water, they shrink. It's pretty simple, but it can be pretty complicated to keep the moisture content the same. So if you can keep the moisture content the same, then the soil won't heave or swell. So if you look at the map, there's expansive soils in California, Los Angeles, San Francisco area, Denver, Oklahoma City, Austin, Houston, DFW area, near Little Rock, Alabama, Georgia, Florida, a lot of places where they build a lot of houses. So how much damage is there? So if you look at in 2019, there were 1.29 million starts. Roughly 20 to 30% of those homes are built in areas of expansive soil, and according to ASCE, 25% of those houses experience problems. How expensive are those problems? Well, ASCE calculated that if you added up all the damage between tornadoes, floods, and hurricanes, it would not equal the amount of damage that's done each year by expansive soils. So let's say you have a failure and you want to hire an engineer. So he'll come out, hopefully interview the homeowner, walk to the house and take notes. Hopefully he'll take pictures, take elevations hopefully as well. Those give you a lot of information. He'll write his report. Keep in mind, if you have a warranty, the report will have to conform to what the definition of the warranty says a failure is, and there may be more questions after he writes the report. But let's say that you have a homeowner that comes to you and you have cracked tile and one door that's rubbing out a square, and maybe they have a estimate from a foundation repair company. So how could you look at it without having an engineer come to the house and spending a month to get the report and $700 to $1,200 in expenses? What if you want to look at it now and decide whether you even need to hire an engineer? Well, let me briefly tell you what the 5 typical symptoms of a foundation failure are. B stands for breaks or gaps around the exterior windows and doors and other damage to them. Cracked interior or exterior doors. I is for interior wall and ceiling cracks. E is for exterior wall cracks or deformations in the siding. F is for floor cracks or distortion. So keep in mind, this is for slab and grade foundations, but it can also be applied if you have crawl space or basements. So again, if the interior soils dry out, then you'll probably have sagging of the main floor. The soils heave on the interior. It'll shove the columns of piers up into the main floor, causing them to deform. So this can be applied to other foundations, not just slab and grades. So if someone sent you these pictures and the window on the right just may not have been caulked, the picture on the right, maybe the jam has just worked over time. Maybe this door is racked. It's hard to tell in the picture, but maybe kids have been hanging on it because they're bored. Maybe it was workmanship. Crack here, maybe the crack is due from expansion and contraction, drying lumber, or workmanship. Maybe it is from a foundation. Picture here of a crack. Maybe the crack is a curing crack. There is two kinds of concrete that will crack and concrete that has cracked. So just one picture won't tell the whole story. You have to look at the whole situation. So let's look at an example here. Here we have a house here. Notice that there is not much brick or stone on it. For example, but you can see at the garage there is a gap at the jamb. Front door is out of square and racked. There is interior cracking, and yes, this is not the only photograph of cracks in the home. As you can see from the first slide of this example, the house does mostly have siding, so it's very forgiving. In this case, you can see that there's a gap in the soffit. The floor is wood, and there are gaps between the planks. So let's look at our checklist. Were there breaks and gaps around the windows and doors? Yes. Were there racked interior doors? Yes. Interior wall cracks? Yes. Exterior cracks? Yes, we saw the gaps in the siding. And were the floor cracks? Yes, gaps in the wood planks. So was it a failure? Yes, in this case, $65,000, what was considered the low end, although that's still a lot of money. So what caused it? You look at the elevation diagram provided by the engineer. You can see that the elevations typically contour lines go from left to right, so it appears the slab is tilted. If you look at the section line A, we'll look at that drawn illustration, and you can see in the diagram that the front of the house is about 1.4 inches high, and the rear is down about 5.4 for a total of about 6.8 inch tilt. If you look at the calculation at the upper right in the drawing, it says that the total tilt is 1.05%. So it exceeds the guidelines, and in this case, it met the definition in the warranty of a major structural defect. So we did repair the home. So what was the reason? The engineer opined that he felt was caused primarily by the topography of the neighborhood and improperly prepared fill material that was used to level a lot during construction. Now, we didn't do post-construction soil testing, but that was the engineer's best guess. So let's look at an illustration of this. You look at the top illustration, you see there's a lot of sloped. So the easiest thing to do is to cut the top of the slope and level the pad and make the lot level. And then add a little bit of bench material for the slab. And then notice over time, the rear heaves and the front settles in this case. So the house heaves because when you remove all the weight on the cut side and the clay soil, all that overburden allows it to move up. Also, you're now adding more water to the soil than it's used to seeing, so it's going to swell. The fill side, even properly compacted fill, will settle 1% to 2%, and if it's not properly compacted, it will settle more. So in this case, it allowed the slab to tilt over time. So let's get another example. In this case, do we have a break? Yes. We have a rack door with the bonus of a crack as well. Many interior cracks in this particular house. Were multiple cracks in the exterior. There were cracks in the floor as well. This is just a picture of the one of the porches. So we look at our checklist. B for breaks, yes. R for rack doors. I for interior wall cracks. We did have exterior cracks and we did have floor cracks. So do you think it was a failure? I think you would probably say yes. Again, it's only $68,000. What a deal, right? So, we look at the example of why maybe it failed. You can look here, this area low, it says 0. This just happened where the engineer started his elevations, but if you look at the contour lines, I know they're a little difficult to read, but we're down 1 inch here, 2 inches here, 3 inches, 4 inches, 5 inches, almost 6 inches low here. We're down 2 inches over here, so the house is clearly heaved right here. Could have been a plumbing leak, but we determined that wasn't the case. So what caused this heave? Well, if you look at this picture here, in 2013, before the lot development, well, by the builder at least, there's a large tree at the front right corner. Google Earth view in 2015 shows that the tree was removed because it was just in the corner of where the foundation was going to be. So look at some illustrations regarding this case. You have the tree, it's removed. I don't know how much of the root system they took out, but keep in mind, that tree takes hundreds of gallons a day. It's hard to believe, but it removes a lot of water from that soil. And that soil in a 20-foot circle at least is much drier than the other soil on the lot. So over time, once you pour the slab, which you see in the third drawing, the slab, the soil underneath the slab, over time will reach what's called moisture equilibrium. And it will be wetter underneath there because it's sheltered from the sun and the wind. There's almost no evaporation. So over time, the system of water that was coming to this area from the tree roots, water still came to that area. This soil became wetter, but since it was drier, it heaves more than the soil at the other side of the house. So you get this heaving effect right here. So in these cases, if you have to remove a tree, you should moisture condition the soil 3 or 4 feet below the surface in order to get it at the same moisture content as the existing soil on the lot. But in this case, we also have an existing tree that wasn't removed. And this tree over time, it's not obvious from the elevation, but this tree over time would remove moisture from below underneath the house because it's a great source of water for trees. So over time, that corner probably would have dropped. So here's an illustration of that. Here at the tree. Tree roots grow over time. They look for moisture. They grow underneath the slab, remove the moisture from the clay soil. And as we mentioned earlier, as the clay soil dries, it shrinks. Since it's a ground supported slab, as the soil shrinks, that portion of the slab goes down. And over years, they're going up, down. Eventually, it just kind of stays down, and it can cause a failure or just a lot of annoying cracks. It depends here too, how expansive the soil is. If the soil is mildly expansive, tree doesn't have as much effect. If the soil is highly expansive, the tree has a lot more effect on what the foundation will do over time. So what can you do to prevent that? Obviously, you can pier the foundation. It's a pretty expensive way to get around it, but the piers will prevent the house from dropping over time. You can install a root barrier as part of the perimeter grade beam of the house. You can also install a separate root barrier somewhere between the tree and the foundation that extends at least the drip line of the tree. Here we have another third example. Again, there's a gap there, fairly large. You can probably get your hand in that gap. House had rack doors, cracks in the walls, cracks in the brick, cracks in the floor. So we think did it meet our 5 typical criteria? Yes. Look at those: breaks, rack doors, interior, exterior cracks, and floor cracks. So was it a failure? Yes. $80,000. In this case, I didn't show you the elevations, but this house generally tilted, maybe not as neatly, clearly not that neatly with all the distress in it. But if you looked at the boring from the subdivision soil support, you can see there was 17 of fill, so at least 17 feet of fill at this location. It's a lot of fill. It's difficult, although the developer did provide a letter saying the fill was properly compacted. Remember what I said earlier, even properly compacted fill settles 1% to 2%. It's very difficult to compact that much fill and not have some soft areas in it. And also, we don't know if one end of the house is sitting on 17 feet of fill and one other end is sitting on 10 feet. We don't know what the topography looked originally. But here's a kind of a grainy photo from Google Earth of really dark areas where standing water is. Ironically, this was a sand pit in order to take out sand for construction projects. And what the developer did was just fill it back up with sand and dirt again in order to extend into another phase of the subdivision. So just be careful. If you have a lot of fill, even if it's properly compacted, it'd be best to pier the house. In this case, let's look at this example. This one's not as clear as the ones we looked at previously. In this case, there was a gap at the garage. That was the only one. No rack doors. Interior crack, and I don't know if I'd call that an interior crack. There were cracks in the brick, but there were no expansion joints in the brick. And in Texas, with our extreme temperatures, if you don't put expansion joints in, the house will make its own eventually. Cracks in the slab, yes, but they were congregated just in the garage and in the laundry room. That was the only two places. So if we look at our checklist, breaks and gaps, yes. No rack doors. No interior cracks, really. Exterior cracks, but those were explainable. Floor cracks, again, you'll see why there were floor cracks. So is it a failure? No. What was the cause? So we look at a Google Earth picture. As you can tell, I like Google Earth, and Google Earth is, if you don't have it, you should download Google Earth Pro onto your computer so you can go back and look and see what was in the lot. Usually goes back to 1995. It's very helpful. So in this case, you can see that there's only a very narrow section connecting the garage and the laundry room. If you look at the plan itself, you can see right here, there's only 4 feet connecting these two. The sole of this location was expansive. They did use piers, but they were only 8 feet deep, and those aren't deep enough. So these two halves will never behave the same. The cracks that appeared in the garage are right across here, and the cracks in the laundry room are right across there. So you just got to have that. Maybe they should have sawed a control joint in there. I don't know. It would have been very pretty, but cracks are even less pretty. Look at this example here. This is actually a house that I looked at years ago. Drove up and there were cracks here above the window. It's pretty obvious. I thought, oh, this corner had to have dropped. But when I walked around the house, there were no breaks or gaps at any of the windows or doors. There weren't any racked interior doors, no interior cracks. Exterior cracks, yes, just in the brick above the garage. Floor cracks, none. We look at our checklist. Look at our 5 most common signs of foundation failure. We have only have exterior cracks, no other distress. And by the way, the floor was fairly level. So, was it a failure? No, not in our case. What was the cause? Well, if you look, all this brick is sitting on the roof. It's being supported by the roof. Going up the attic, you see the brick is sitting on the OSB. I'm surprised it hadn't fallen into the attic already. So I told the superintendent that needed to be corrected immediately, and they took care of it. Another example here. There are breaks and gaps. Not this house. No rack doors. No interior cracks. No, not really any exterior cracks. The house is probably 8 years old. But there were hundreds of feet of cracked tile. 2/3 of that floor was tile. It had cracks all running through it, and the homeowner was very upset. She even removed the tile and said, see, the foundation's cracked. And everywhere she had removed the tile, it was that same 1/32 of an inch thickness. It was everywhere, but the slab was still level, and there was no other distresses. So look at our checklist. You don't have anything checked off except floor cracks in this case. So was it foundation failure? No. But what was the cause? So clearly when there's all that cracking going on but no foundation movement, in this case, I would surmise that either the mix was incorrect or somebody added a lot of water to the mix the day it was poured, and the slab had a lot of curing cracks in it. So anytime you have tile and the foundation cracks, you have a good chance that those cracks will be reflected into the tile. So you did, let's say in this case, you're going to have a foundation repair. What do you need to do? So if you're going to have an engineer look at it, you want to have the engineer come up with a plan of repair. One, he's the expert, and that would be a prudent path to follow. Also, by having the engineer come up with a plan of repair, that will give you a plan to go by. So when people bid your repair, everybody's bidding apples to apples. They're not all coming up with their own ideas of how to repair the slab. Our contractors camera the plumbing lines, and I'll explain why in a little bit. Have them bid the repair. Again, if you have a plan of repair, everybody's bidding kind of apples to apples. Choose one of the bids. Have the homeowner sign a release. Here, Mrs. Jones, this is the repair we're going to undertake for you on your behalf, and have them sign off on it so everybody's clear what's going to be done. Coordinate with the homeowner. This is very important. What day are you going to start? They need to have the garage cleaned out. If you're in a case where, again, our case, we spend money for tunneling. That's not done everywhere in the U.S. If you have to remove furniture or carpets, all it has to be pre-planned. So on the day their foundation repair company shows up, you're all ready to go. If it's complicated repair, have a construction meeting with the homeowner. There may be several phases of work that have to be done, and different things have to be scheduled. And again, the homeowner may have things that they have to do. We tunnel below the foundation, and that's very expensive. Tunneling costs about $150 a lineal foot. And so you want to tunnel as little as possible. If you're doing a high lift, there's a good chance you're going to break plumbing. So if you can put the tunnels where the plumbing is, then you'll save money on plumbing repairs. And again, the point of tunneling is so the homeowner can stay in the house. If they're staying in the house and you've broken a bunch of their plumbing, then there are going to be times where they can't use the plumbing. And again, that makes it more difficult for them. So if you can avoid those issues, that's important. Lift the foundation. And then depending on your engineer, he may want to look at the house halfway through the lift. He may want to look at the house just at the end of the lift. This is something we'll have to coordinate with the engineer that did the plan of repair. Repair the yard. So you saw in the photo that foundation repair can be messy. And once you clean all that up, the next step is very, very important. Most of the houses that we repair, we are lifting or moving back into an acceptable position. If you're just tiling it to keep it in shape, maybe it doesn't have to sit so long. But for a lot of the repairs we do, we need the house to sit for a period of time as it adjusts to its new position. If you ask our cosmetic contractor, he will say he wants the house to sit for 6 months. A homeowner, if it was up to them, you would finish the repair on Friday, and then you would start the cosmetics on Monday. But that's not a good idea. The house should sit for at least a month before you start doing cosmetic work. While the house is sitting, you can get bids for the cosmetic work. When that time is up, you're ready to go. Have the homeowner sign a letter at the end saying that the work is done to their satisfaction, and hopefully you have met your goal of either preventing additional movement or putting the house back in order. Keep in mind, foundation repairs are expensive. Our typical complete lift runs us generally around $75,000 to $100,000, depending on the size of the foundation, depth of the piles. There are other considerations, but the biggest one is the size of the foundation. If you, the builder, are hiring the foundation repair contractor, keep in mind that our claims department spends about 100 man-hours per house if everything goes right during a repair, keeping up with the communication, communicating with the contractor, all things that are involved to keep the repair to go as smooth as possible. If you have a complicated repair or things don't go well, it's hundreds of man-hours. We've had houses that have taken a year to repair because of just all the different steps that you have to go through. And sometimes they can be very complicated. So again, foundation repair is expensive and time consuming. So just to be brief, the 5 most common signs of foundation failure are B, for breaks and gaps around the exterior of windows and doors. R, wrapped interior or exterior doors. I, interior wall and ceiling cracks. E, exterior wall cracks or deformations in the siding. F, floor cracks or distortions. So thank you very much for coming and listening to our common culprits of foundation failures and structural damage. Thank you for your attention. If you have any questions.
Great. Well, thank you so much, Brant. We do have a couple of questions, and if anybody else on the line wants to go ahead and type your questions in the questions box, we'll get to them. But let's start with a few that we have. So how long am I responsible for the structure of my home?
I'll answer that one. All right. Can you hear me okay?
Yes, Lisa, thank you.
Great. Well, every state is different with their laws, but by the NAHB guidelines and standards, performance standards, every builder is responsible for 1 year workmanship, 2 year systems, and 10 years of the structural integrity of that home. So that means that without a warranty, that builder, if you had a structural failure within years 4 and 7, which most of them happen between that time period, then you can be liable for paying for that structural damage. That's it.
Oops, sorry, I had it on mute. Here's another question for us. If a foundation fails, but a structured engineer designed the slab based on soil analysis performed by them, and the engineers inspect the foundation prior to pouring, what else could or should the builder have done to reduce their risk?
Well, one thing that I see is many times builders do get, again, a foundation design and a soils report, but frequently I find they don't read all the details on the foundation plans, and they don't read all the soils report. I mean, I know all builders are different, but frequently the builder gets the soils report and he just gives it to his engineer. His engineer will design the foundation per the requirements of the soils report, but there are a lot of details in those plans, in the foundation plans, that need to be followed. For instance, I talked about trees. And many engineers, some engineers say trees can be within 10 feet of the house. Some say 20 feet. Some say there should be no trees within half the mature height of the tree. And they'll go do the foundation inspection. They may mark on their inspection report there's a tree, but they expect the builder to install the root barrier or do the things necessary. I've read soils reports where the soils report said, there's fill on the lot and it's undocumented. We don't know if the fill is good or not. But the engineer will still design the foundation, assuming that the builder knows that the fill was properly compacted, and the builder will build the house without having read the soils report about the fill issue. So again, it's very important you read the entire soils report. You shouldn't have to understand everything in it, but you should certainly know if there's fill, if there's trees that are going to be a problem. There's all kinds of little details in there that one has to pay attention to, and if one of those is left undone, it's always a potential for a problem later.
Great. And in a follow-up to that, in that case, is there a general response as to who is responsible for the failure?
It's hard to say. It varies. If you read everything in the soils report and read everything in the engineer's plans, then maybe something was overlooked. But in areas of expansive soil, you can do everything right, and there's still always the risk that there's going to be a problem later.
And Carrie, eventually, most likely, it's going to fall back on the builder on this responsibility.
Good to know. Gotcha. Thank you, Lisa and Brant.
And it's real quick, I just want to interject real quick. like I said, every state is different in their laws. And so if somebody has some questions, feel free to reach out to us, and we're going to get them in touch with their local representative that is an expert in their area. Okay.
Fantastic. Great. Another question here is, what's the cost breakdown between builder, developer, and homeowner?
In terms of what? The cost of the house?
Yeah, it doesn't have any information. I'm assuming maybe in the event of a failure, and I would guess that's dependent on who's responsible, but let's just presume in the event of a failure.
So in the event of a failure, I've been to multiple mediations, and rarely is the developer involved. I don't know the reasons for that, but I think typically that developments are set up as limited liability corporations, and once the development's done, it's done. Builders are, like Lisa said, are usually, if there's no warranty, the builder is going to be responsible. And even if the developer's at fault, the builder's going to be responsible first and accountable, and he may have to go after the developer if that's possible. So homeowners are also accountable, because I've seen numerous times where the homeowners are not maintaining their yards, or they've altered the grade, or I've seen cases where, there were no trees in the lot, and they planted a fast-growing, species such as a mulberry, and 9.5 years later, the mulberry is affecting the foundation. So the homeowner is accountable because they're responsible for maintaining the house and making sure that they don't create situations that cause problems. And the builder's accountable in order to build the foundation per the plans and specs. And but unfortunately, it's usually the builder that takes the brunt of it, no matter whose fault it is.
Good to know. Another question here is, do I need to worry if I am building on rock?
Yes, it's not always as clear as it might seem. Sometimes when you install the foundation, you may hit what's called the lens of rock. The rock that layer may only be 6 inches thick, but then there's several feet of clay soil beneath it. And so the rock, although you think is affording you a situation of no movement at all, when in fact the rock is just a floating layer within the layer of clay. So it's important that if you hit rock, that you either drill holes in it or do some kind of additional inspection to make sure that it is a solid layer of rock. Additionally, there's been instances where half the house is sitting in rock and the other half is sitting on expansive soil. That two halves will never behave the same and will likely cause issues over time. So rock can be very good, but you have to make sure of the situation that you're in.
Excellent. Well, that is it for our questions. I want to thank you very much, Brant, Mike, and Lisa, and the entire Centricity team for your ongoing support of the HBA and HBA members. And I want to thank our audience for your time today as well. You will receive a copy of the PowerPoint and the recording. And let us know if you have any other ideas for future webinars. But again, thank you so much, Mike, Lisa, and Brant. And I hope you all have a great day.
Thank you.
All right.
Thank you.